Hello students, today's agenda is to check homework. We're going to have a small warm-up and today we're going to learn about the triangle inequality theorem and you will be able to work on 8.7. Today students will be able to apply the triangle inequality theorem to find the lengths of possible of the third side of a triangle. Sorry about that. Okay, so we're going to start with the warm-up because we're going to be using the inequalities that we learned in module K and also in Math 1. Okay, so the first thing that we do to solve this inequality, we're going to add 2 to both sides. And so we get 3x is greater or equal than 18. If we're multiplying, the opposite of multiplication is division, or the inverse operation is division. So x is greater or equal than 6. We don't need to switch the symbol because this is positive, okay? The coefficient of x is positive, we just keep the same symbol. To graph, I'm just gonna put the 0 and the 6. We're going to put the circle where the 6 is, and because we have this here, the equal sign means it includes the 6, it equals to 6 as well, and it's also greater, okay? Greater, what is greater than 6? Well, we have the 7, the 8, 9, those are greater than 6, okay? So this, I said, if there is a little pencil in here, it helps you close the circle. For the next one, we have parentheses, and that means that we can do distributive property in here. So negative 2 times 4x is negative 8x. Negative 2 times negative 1 is positive 2, and is less than negative 14. We subtract 2 from both sides to cancel the plus 2. And so we get negative 8x is less than, since it's 2 negatives, it's addition of negatives. So it's negative 16. The inverse operation of multiplication is division, but remember that in division we keep the sign, because negative divided by negative gives me a positive. Otherwise, I would end up with a negative x, and I don't want that. Anytime that we're dividing by a negative or multiplying by a negative, that means that this inequality symbol is going to switch. So instead of less than, it's going to be greater than, okay? And so in here, it's gonna be x is greater than negative 16 divided by negative 8 is negative divided by negative is positive. 16 divided by 8 is 2. For my graph, I put 0, I put 2. This is where my circle is going to be. I don't have a little pencil, so I cannot close the circle. I cannot shade in the circle. Also, it just means x is greater than 2. It does not include the 2. And what is greater than 2? Well, we have 3, 4, 5, etc., etc. So that means that my arrow is going to go on that direction. The last one, we have combined like terms. And we have in here negative 8x and positive 7x gives me negative x. I bring down the 5 is greater or equal than negative 7. If I'm adding 5, the opposite or inverse operation is to subtract 5. That cancels because 5 minus 5 is 0. Bring down the negative x is greater or equal than. So when do we switch the symbol? Only in multiplication and division of a negative, okay? Not in subtraction, because some people get confused with this. Only in multiplication and division, and if there is a negative sign in there. Okay, so now -7 minus 5. Again, this is two negatives, so we have -12. Okay, it's addition of negatives. Finally, if we have a negative variable, we're going to divide by -1, because negative divided by negative gives me positive, and x divided by 1 is x. And the fact that this is a negative is going to switch the symbols. Instead of greater and equal, it's going to be less or equal than. Negative divided by negative, positive. 12 divided by 1, 12. I create my graph, 0, 12. That's where I'm going to put my circle, and the little pencil at the bottom gives me the ink to close the circle. Okay, that equal closes the circle. And this says that it says that x is less than. Remember that the arrow represents the x, so less than are over here, because less are the 11, 10, etc., all the way to 0. Okay? Okay, now that we have that, let's go to the main lesson. So you're going to write this. It says triangle inequality theorem. The sum of the smallest two sides must be greater than the longest side. So let me show you some sticks that will help, or that I used in class. So I gave different students, and let me see if I can zoom out. I'll bring that back. I gave students these sticks, and they formed different triangles. And so I asked what happened in some cases. So some got the same color sticks, which is the same size, so that's equilateral triangle. Some of them also form something like this. These are different sides, so scalene triangle. Some got something like this. And so that's an isosceles triangle because it has two congruent sides. Sorry, I can't form them correctly, but that's an isosceles triangle, two congruent sides, and remember that the base angles are congruent as well. But then some students got something like this, which would have been an isosceles triangle, but what happened? What happened there? Well, two of the sides are too small that they cannot form a triangle. And that's what you just read. The two smaller sides have to be, when you add them together, they have to be greater than the third side. But in here, these two smaller sides do not add to be greater than the third side. Also, some others got, let me get some more out. Some others got something like this. And I told them to start from the bottom like this, but they noticed that the sides are exactly half. Okay, so they cannot when you add this together, they cannot be this cannot be equal to the third side either, because otherwise you're just going to form two lines next to each other, okay, or even overlapped. So when you add the smallest two sides, the sum has to be greater than the third side, okay? Not equal, not less, because otherwise they don't form a triangle. They form two overlap lines, or this one doesn't even, they don't even touch, they don't even close, okay? So having that in mind, so let's move that to the side. Having that in mind, let's put it into practice. Okay, the sum of the smallest two sides must be greater than the longest side. So in here it says, can a triangle have the given lengths? Explain. Well, on the side we're just gonna use the two smaller sides. 5 plus 8, is it greater than 12? And this is gonna be question mark. We add 5 plus 8 is 13, is greater than 12. So we say yes. And the explanation will be because 5 plus 8, you can put in words is greater than 12 or is greater than 12. Either one is fine. You can replace this with words is greater than 12. Okay, and you just put ending point. The next one, 2 plus 5 is greater than 7. Again, this is a question. Is 2 plus 5 greater than 7? No. 7 is not greater than 7. It's equal. So we can say, again, using just a mathematical sentence or words, no, because 2 plus 5 is not greater than 7. And you can just write the words that I used, okay? The next one is 6 plus 2 is greater than 6 plus 2. Is it greater than 11? No, because 6 plus 2 is 8, is not greater than 11. So we say no, because 6 plus 2 is not greater than 11. Okay, so it's very simple. This is very straightforward. So you just add the two smaller sides. If they're equal or less, then no, they cannot form a triangle. But if they're bigger, greater than the third side, then yes, they can form a triangle. Okay, so find possible side lengths. Sometimes they're gonna give us two sides. Okay, if a triangle has sides of length 7 centimeters and 9 centimeters, what is the length possible for the third side, or lengths, because there is several, right? Okay, so what you're gonna do is that you're gonna use these two, and you're gonna say that because we don't know if x, which represents the third side, is smaller or bigger or in the middle of these two, so we're gonna be placing them in different parts. So we're gonna say x plus 7, meaning using one of the sides, x plus 7 is greater than 9. So I'm using the information that they gave us, okay? For the other one, I just switched them. X plus 9 is greater than 7. And finally, 7 plus 9 is greater than x. It seems like I switched them, but that's fine. 7 plus 9 is greater than x. And we'll see it with another one where I don't have the setup already. After I do the setup, I'm just going to subtract. If I'm adding, I'm going to subtract 7 from both sides. And so x is greater than 2. In the next one, it says that I'm adding 9, so I'm going to subtract 9 from both sides. And so x is greater than 7 minus 9 is negative 2. Since this is a negative value, and we're talking about distance or measurement, we cannot have a negative side. Okay, so we're just going to cross that out. Finally, we have 9 plus 7. Well, 9 plus 7 is 16, is greater than x. Okay, so it means that my possible side for the third side is going to be greater than 2, or x is less than 16. Okay, so that's what this is telling me. I can write it in a different form, and this is very easy. You can just get the smallest of the two numbers, so it's going to be 2, the biggest number, which is 16, and you're going to put x in the middle, okay? And in here it says that x is greater than 2, so x is greater than 2, meaning that 2 is less than